Welcome again, YouTubers, and welcome to this, I believe it's the sixth video in my STM32 Getting Started series of videos. Today we will be looking at external interrupts so we can respond to, for example, a key press. But before we actually start looking at this, I just want to show you a little detail. Remember the last video we ended up printing out the loop count. How many times is the main loop actually executing between these various updates? And we came out to about 2.6 million times it's looping around. But an interesting observation I just made was that if you go into the project properties under settings, C++ build settings and optimization, you'll see by default STM32 CubeID is not optimizing the C code at all. An interesting thing is if you do one of the lowest level of optimization, which is optimized for debug, and apply that, we can rebuild the index and execute that. And there we go. You will see that it nearly doubles the speed. So the main loop is executing 2 times more than it was without that optimization. Now, at this point in time, I don't know why. I will probably be looking at that in a later video. I just thought it was an interesting observation. Anyway, back to interrupt and external interrupt. And we're currently looking, using our black pill board, and you can see it running our code here. And if you look at these black pill boards, most of them have a key, which is called user key. If you look at the description of the board, you can see they call it a user button, and it is a button and it's connected to PA0. And the mode is interesting. It is active low. In general, that means that when you push the button, the signal goes low. But in order to confirm this, we really should be looking at the schematics. And in the schematic, we have the key up here. We can also see this is only on certain versions of the board. I can't read the Chinese, but I assume it says roughly the same. And we can see here that when the button is shorted, it would short to ground. But there is no pull-up resistor, so when the button is not pressed, PA0 is undefined. It is neither high nor low, and that is not a good place to be. So we need to keep that in mind, and there's a solution to that, which I'll get back to later. So PA0, active low. So let's look at our STM32 CubeMX. So we have the PA0 down here, and we can define that as a GPIO input. We can also, however, define it as an GPIO X'd. So that's an external interrupt. So in other words, an interrupt will be generated, maybe, we'll get back to that, every time this pin is defined. So let's call this button. We now have a button GPIO defined, so we'll go into system core GPIO, and we have our PA0 here. And we see by default it is defined as external interrupt mode. Hang on. With rising edge trigger detection. Remember, this is active low, so when you press the button, it actually is a falling edge, which is there, or when you let it go, it will be a rising edge. So we leave it at the rising edge. You can also see here that we can define a pull up, pull down. Remember, it is active low, so we need to enable a pull up resistor on this particular pin. That means that when the button is not pressed, the signal will be clear and high. When we press the button, it'll go low, and there will be a falling edge trigger on that. So let's generate the code based on this setup. No, I forgot one thing, sorry. And I always forget this, so keep that in mind. We also have to enable the interrupt. Right now we have an external interrupt mode, but in the NVIC we have not enabled the interrupt, so we need this line 0 interrupt to be enabled in order for this to actually work. Yep, that should be it. Project, we generate our code. Now let's look at the code. Now, fortunately, handling these interrupts is the STM32 QPIO HAL have a lot of helpful functions for this. If we open the declaration of the GPIO init, you'll see that in this file there is actually, this is all the GPIO functionality in the HAL library, but there's a lot of documentation provided in the source code. We will notice here that there is actually a GPIO external interrupt, so GPIO external interrupt callback, and this function will be called every time there is an interrupt on that pin. So, and it's defined in the source code as weak, and that means we can override this function in our code. So if we copy the definition file and go in here and up in our user code, we can define that. So this function will be called every time an interrupt happens. We need to check in the code which pin is actually being interrupted. So we can do that like this. If GPIO pin equals button pin, I think it's called button pin, then we do. If it's something else, we just for now ignore it. Now, these callbacks needs to be kept as short and sweet as possible. So rather than actually doing any functionality here, it would be better just to set a flag. So we define a private variable, which could be an 8-bit, say button press, and we set that to 0. We actually don't need to set it to 0 because it's a global variable. Global variables are always initialized to 0, but never mind. And if this button interrupt happens, we simply set our button press equals 1. Then we can handle all this down in our main loop. So if button press equals 1, then we need to do some stuff, and we need to set button press equals 0. Now for now, just to show that it's working, let's just do a printf button pressed. Let's try to execute this. There we go. So now we should be able to press the button, and when we release it, remember we were triggering on rising edge, there should be a a button pressed, which is being generated every time the button is pressed. So now let's do something based on that button press. And one thing we could do is to change the speed of the LED, how quickly the LED is flashing. So let's define some variables up here. Private variable, we could call it, we need to count to 500 maximum, so we could use 16 bit values, 16T button, blink delay. We defined, and we want to define that as an array, and we want to set it equals, by default we were using 500. We can do one that is 250, and we can do one that is 100, just 3 different speeds. Remember, this is a delay. If we look at the loop, we basically want to count up to a value, and then we toggle the LED. So let's have those. We need a few more. We need a current status, which we could call blink delay equals 0. So by default, we are using the first one in this array, and we could do, no, that's pretty much what we need. So now, down in the main loop, rather than waiting for 500, we will say if it's bigger than blink delays, blink delay. So that will be the value of 500, and if we set this to 1, it will be 250 if we set it to. So let's run with this and just verify that it is still working. So we execute, we show our device, and it is still blinking at the speed it was before. So far so good. So now whenever the button is pressed, what we basically need is to increase the what was it called, the blink delay, every time the button is pressed. However, if blink delay is greater than or equals size of blink delays divided by size of blink delays 0. That will give you the size of the array. If that is the case, we need to set blink delay to 0. This should basically do the trick. Every time the button is pressed, it will increase blink delay, which is an array counter into this array, and it should end up blinking faster. Let's try this. Let's start by trying to build it, see if it builds without errors. It did. We are in luck. Let's try to fire it up, and let's look at the debug code, and let's look at the device. And now I press the button. Can I do this? Yeah. See, it already blinks faster, and now it blinks very fast, and then it should go back and blink very slow. So we have just turned this device, well, it basically created a user interface, a very simple user interface, and perhaps a very stupid user interface, but a user interface nevertheless. It is that simple to respond to an external interrupt, and well, play around with it. It's the best way to learn. As usual, I will read all the comments. I don't have that many views. So feel free to ask questions in the comments. I will answer those questions either in the comments or I'll answer them in a later video. Feel free. I hope you enjoyed this video and learned something interesting. Bye bye. Oh, I should say, please subscribe and like. I'm supposed to say that, I think, every day. So bye bye. Enjoy your day.